Lesson 2.5, Evaluating Absolute Value Expressions. The essential question is, how many solutions can an absolute value equation have? And our new vocab word is absolute value. This vocab word should be kind of a review for you. I'm sure you've learned about absolute value in the past. We are going to extend that knowledge though. The absolute value is the distance from zero on a number line. The distance from zero on a number line. Now I want you to think about this absolute value equation. Absolute value is represented by these two bars. So if the absolute value of something equals 7, what could x be equal to? What could x be equal to? So you may recall that the absolute value of 7 is equal to 7 because the number 7 right here is 1, 2, 3, 4, 5, 6, 7 units away from 0 on the number line. Hopefully you also remember that there's another number that has that same absolute value. That would be -7. The absolute value is the distance from 0. The absolute value from -7 to 0, 1, 2, 3, 4, 5, 6, 7, is also 7. Distance cannot be negative. So that's why both of these distances are +7. If you don't believe me, I want you to think about when you measure something, when you measure a distance, what do you take out to do your measuring? You may take out a ruler, you may take out a yardstick, a meter stick, a tape measure, whatever it is that you take out to measure with, it does not have negative numbers on it. So a distance cannot be negative. Now, very specifically, I want you to notice on these next examples, there are 4 of them. I want you to notice what is within the absolute value bars and what is outside of the bars. Because the bars are the part that tell you to find the distance of what's inside. So these 4 expressions that I just wrote do not all represent the same thing. The absolute value of 5 is 5. The number 5 is 5 units from 0 on the number line. So is the absolute value of -5. Now, these next 2 examples, what I want you to notice is that there is an extra negative sign out in front. You can think about that negative sign as meaning the opposite of, or like -1 times that absolute value. What that negative sign does is it sticks, it stays, it's on your answer. Because the part inside the bars is what turns into the +5. Then you take that negative sign that was out in front and stick it out in front, and it gives you a negative answer on both of these. So the bars, after you evaluate what's inside of them, kind of like parentheses, the bars go away. They go away. The negative sign out in front of the bars creates a negative number. Okay, now we're going to do a little bit of evaluating. This should be a review for you. I think you've seen this before where you just plug it in, plug it in. So on the first one it says x equals 5, so I plug in my 5. Now using the order of operations, I want you to think about absolute value bars like parentheses again. So you've got to simplify what's inside of them. 5 minus 7 is -2. Then the absolute value of -2 is +2. Now the bars are gone. So my final solution is 17. On the next one, 17 minus y, and then plus 23. Y is 3, so if I plug in 3, 17 minus 3 is 14. That absolute value is 14. Remember that the absolute value bars do not mean the opposite of the number inside. They mean the distance, and the distance is always positive. So a positive number stays positive. So my second example, the answer is 37. Okay, two more with a little bit more going on. If I plug in 5 and then minus y, that means minus -1. And then plus z, which is -4. This is a little tricky. When you plug in a negative number, you may want to put it in parentheses. You don't have to, but sometimes it helps. Now, inside of these absolute value bars, 5 minus -1, that turns into a chunky plus. 5 plus 1. So, 5 plus 1 is 6, and the absolute value of 6 is 6. So 12 minus 6 plus -4, 12 minus 6 is 6, plus -4 is 2. So be careful with your sign, be careful with your signs when you're substituting, and make sure that if it's a negative number, you remember that it's got its own negative sign when you plug it in. The next one says -y plus x, or the opposite of y plus x. So if y is -1, and I substitute that where the y is, notice that I still have that negative sign that was in the problem before I did my substitution. So that double negative turns it into a +1. I also think it might be helpful to say up here that this means the opposite of y. So if y is -1, the opposite of y is +1. Okay, now still inside my bars, the absolute value of 6 again is 6. So I have 6 minus 3 times -4. I do not subtract before I multiply. Not ever in my order of operations, PEMDAS, so please multiply. -3 times -4 is +12, so 6 plus 12 is 18. Remember that you may want to do a little tick-tock or add the opposite, if that helps you, so that you clearly understand that that -3 is the same as a -3, as adding a -3. So you're multiplying -3 times -4, which is a +12. Okay, now, switching over to some equations, because those were expressions. They didn't have an equal sign. They were expressions, plug it in and solve. Now we've got an equation. So remember what I asked you already. I said if the absolute value of x equals 7, what could that x be equal to? And we said it could be 7 or it could be -7. Because both of those numbers, the absolute value of them, if I plug them in, the absolute value equals 7. So there are two different solutions to that absolute value equation right there. So there are always going to be two solutions. So my next one says the absolute value of x plus 1 has to equal 5. Well, what are the two numbers that this x plus 1 could be equal to? What are the two numbers that have the absolute value equal to 5? Well, one of them is 5. What is the other one? -5. Those are the two things that have an absolute value of 5. So if I solve these two equations, I am going to get 4, and I am not going to get -4. I am going to get -6. If you don't believe me that those are the two solutions, plug them in. So here's what I started with. Plug them in. If I plug in 4, I get 5. The absolute value of 5 is 5. If I plug in -6, I get -5. The absolute value of that is absolutely 5. So your two solutions. Do not be lazy. Do not get lazy on us. Don't solve one of them and then say, oh, got them both, 4 and -4. You will get the second solution wrong. So please solve them both. Okay. Solve and graph on a number line. Well, it says 3t minus 1. That absolute value has to equal 11. So that means to me, the absolute value of 11 is 11, and the absolute value of negative 11 is also 11. So solve both of these, 2 steps, add 1 on both of them. This one gives me 12. This one does not give me negative 12, it gives me negative 10. Divide by 3, and I get 4 for one solution, and for the other solution, negative 3 1/3, or negative 3.3 repeating. Graphing them on a number line means, here's my 1, okay, means graphing those 2 points. So 4 is one of my solutions, and negative 3 1/3, which is about right here, is my other solution. So you're just graphing those 2 points on a number line. Now, what happens when we see a negative? What happens when we see a negative over here? I want you to think about this. This problem is saying that the absolute value of this stuff, whatever this is, its absolute value has to equal negative 1. I want to know, can the absolute value of anything equal negative 1? No. Why not? Distance can't be negative. So what that means is there is no solution. Why? Because distance can't be negative. Distance can't be negative. Okay. On the last 2, you might be saying, well, you made that one a negative. No, this said that this distance equaled a positive 11. So we were trying to figure out what that part inside the bars equaled, what it equaled, so that its distance away from 0 was 11. So when we solved our equations and we set it equal to 11 and negative 11, we don't have any absolute value bars anymore. We don't have any bars anymore. So that's why we can have a negative 11 and solve it. Okay, can an absolute value equation have one solution? This is a challenge question that we ask you. And we ask students to really think about it and come up with ideas. And then right here, this is a click and drag where we have students click and drag. This one has a negative, no solution, no solution, no solution. 2 solutions, because I could set it equal to 1 and negative 1, set it equal to 5 and negative 5, 14 and negative 14. Look at these 2. These are the 2 that have one solution, because there is no opposite to 0. If the distance away from something, the distance away from 0 is 0, means you're right there. You're on 0. So those you can only solve for one solution. Okay, last part. The temperature of a cage for a pet gecko should be about 80 degrees, give or take 5 degrees Fahrenheit. Find the maximum and minimum temperatures, and then write and graph the range of acceptable temperatures. Well, give or take 5. Give or take 5. That means that it could be 5 either way. So it could be plus 5, or it could be minus 5. So 5 in either direction. So the minimum, if they want it at about 80, so I'm going to put my 80 right here. So the minimum, 1, 2, 3, 4, 5, if I go down 5, I get to 75. The maximum, if I go up 5, I'm going to get to 85. So here's what that graph would look like. Any temperature in this range is good. So the minimum is 75 degrees, and the maximum is 85 degrees. So we can write that range like this, and that would be the range of acceptable temperatures, anywhere from 75 to 85 degrees. The next one, same idea. Average temperature is 1 degree Fahrenheit, and it may be 4 degrees Fahrenheit, warmer or colder. So the maximum and minimum, so my starting point is my 1 degree Fahrenheit. Now 4 degrees warmer would put me at 5 degrees, so my maximum is 5 degrees. 4 degrees colder though. Over here, next to 1, I would have 0, -1, -2, so this would be -3 degrees. So it gets a little trickier when you are working with positives and negatives. So my range is -3 degrees to 5 degrees. And my graph, I'm going to have closed circles on each one because I include those points, and I'm going to connect it in between. Now you're ready to write your summary, so go back and read your essential question, and then write your summary, and here are your homework problems.